Hello, so this is the solution of the worksheet number 1 related to section 2.2 and 2.3. So we will start with the MCQ questions. For MCQ number 1, we have the computation of the limit x approaches minus 5 of the rational function x squared minus 25 over x squared plus 2x minus 15. Okay, guys. All the time here, we start by the substitution to see the situation of the limit. So what is the substitution? This is in fact to take the value of x and substitute by the a here, which is in this case minus 5. So the substitution will give 25 minus 25 over 25 minus 10 minus 15. So simple computation will give 0 over 0. And this is, by the way, what we call it in the lecture indeterminate form or indeterminate case. Okay. What does mean indeterminate case? It means that we cannot conclude right now the limit. We have to continue and to change the expression of the function and remove this indetermination. So if I compute, I continue the computation, then I will factor here the function. The numerator is factored x minus 5 times x plus 5 because the numerator is of the form a squared minus b squared. And also in the denominator, I will factor this. It's x plus 5 times x minus 3. Okay. In general, for factoring, we try to guess and see what happens if it is correct or not for the factoring. Here, I have x times x, it's x squared, and 5 times minus 3, this is minus 15, and the middle term 5x minus 3x, which is 2x. So my factoring is correct. Now I can simplify by x plus 5 and x plus 5. So I will get limit x approaches minus 5 of the remaining part, which is x minus 5 over x minus 3. And now I can substitute. So it's minus 5 over minus 5 minus 3. And simple computation here will give 10 over 8, which is also by simplification 5 over 4. So the answer here is C. Good. So now we can continue to the MCQ number 2. MCQ number 2 is computing the limit when t approaches 3 of the function 3 minus t over root t plus 1 minus root 5t minus 11. As usual, we substitute t by 3. So in the numerator, it's 0. And in the denominator, root 4 minus root 5 times 3, it's 15 minus 11. So again, 4. So clearly here we will get 0 over 0, which is indeterminate 4. So we have to continue and change the expression of the function. This is equal to limit t by approaches 3. Now the change of the function is specific for the square root now, because since we have here in the expression square root, to make a change to this function, we will use what we call the conjugate. What is the conjugate? You see here that in the denominator, we have the expression with the roots. Okay, so if you have any expression with roots, 2 or 1 root, then you just switch the sign between the two terms. There is a sign between the first and the two terms. Sometimes it is minus, sometimes it is plus. So the conjugate will change this sign to the opposite. If it is minus, then I will put plus for the conjugate. If it is plus, then I will put minus. So in our case here, it is minus, so the conjugate will be plus. Okay, so my expression will be the following. 3 minus 2 minus t. Then what I have in the denominator, and I will put it between parentheses, because it will be one block for this expression, t plus 1 minus 5t minus 11. Okay, and now I will introduce also the conjugate. So since I will use the conjugate in the denominator, so root t plus 1 plus root 5t minus 11. Okay. And since I multiplied by the conjugate in the denominator, I will do the same thing for the numerator to not modify our expression, our function, of course, to be identical to the previous function. Okay. Good. Now, remember that for this expression, which is an expression times its conjugate, no need to do any computation. This is of the form a minus b times a plus b. Your a here is this quantity, and your b is this quantity. Okay, so automatically we have the formula here. This is equal to a squared minus b squared. So no need to do the computation. When you use the conjugate, directly put the result. No need to expand. Okay. Now, this is for the denominator. I will continue the computation here. So it is equal to limit t approaches 3. Denominator, which is already root t plus 1 squared minus root 5t minus 11 squared. And in the denominator, I will keep it like that. 3 minus t times the conjugate, which is root t plus 1 plus root 5t minus 11. Now, what happens in the denominator? We'll get this square root disappeared because we have the square. So its limit t approaches 3. 3 minus t times root t plus 1 plus root 5t minus 11 over. Now be careful of this minus. You have minus in front of this expression after simplification of the square root. So t plus 1 minus the whole thing inside the square root. So it's minus 5t minus 11, so plus 11, okay? And if you do the computation for the denominator, you will find the following. So it is equal to limit t approaches 3, t minus 5t, that's minus 4t, 1 plus 11 plus 12. Okay, and 3 minus t times the conjugate here. We'll gain some time to write it quickly like that. So what happens in the denominator? I will take 4 as common factor. So it's 4 minus t plus 3. And you see here minus t plus 3, it's the same as 3 minus t. So I can simplify this times the root t plus 1 plus root 5t minus 11. Okay, so simplification this by this, and then I can substitute the t equal to 3. Okay, so this is equal to limit t approaches 3 of the remaining part, which is only 4 in the denominator, and root t plus 1 plus root 5t minus 11. And substitution will give me equal to root 4 plus root 4. It is 15 minus 11 over root 4, over 4, sorry. So 2 plus 2, that's 4, and the result will be 1. So my answer in the worksheet will be A. Good. So we can now continue with MCQ number 3. Let's move a little bit here. Okay. So MCQ number 3. We want to find the equation of vertical asymptotes of the function f of x. Here we have a rational function. So we will try to find the candidates for the vertical asymptote. But before that, let me recall you what does mean vertical asymptote. If you have one of the following situations, so this is the remainder, if one of these situation happens. I limit x approaches a of f of x is equal to plus or minus infinity. 2, limit f of x, x approaches a plus equal to plus or minus infinity. And third, limit f of x when x approaches a minus 1 is equal to plus or minus infinity. Then I can conclude that x equal to a is a vertical asymptote. Okay. So yeah. So usually what we do for to find the vertical asymptotes is here we have denominator. So we will try to find the candidates for vertical asymptotes. Okay. What does mean candidates? For me, it means denominator equal to 0, where I have a problem. Okay, so I will solve for x the following equation: x squared minus 5x plus 6 equal to 0. By simple factoring, I will get x minus 3 times x minus 2 equal to 0. That means x equal to 3 or x equal to 2. Good. So these are candidates for the vertical asymptote. What is remaining to confirm that one of them or both of them are vertical asymptote? We need to compute the limit at this point. So limit f of x when x approaches 3 is equal to the limit of the function. Now we have to do the factoring for the numerator and denominator. So in the numerator, since it is here my expression, so I will put the factoring, which is x minus 7 times x minus 2. I recall you that each time you do factoring, please verify the factoring. It doesn't matter if you make a mistake. Then the purpose of factoring is to guess this factor and to confirm that it is a good one. Okay, so each time you write the factoring, make the check. Here the check x times x, it's x squared, minus 7 times minus 2, that's plus 14, and minus middle term, minus 7x minus 2x, so it's minus 9x, and my factoring is correct. We already have the factoring of the denominator, which is x minus 3, x minus 2. So clearly here, we can simplify x minus 2, but we cannot simplify x minus 3. So x minus 3 still make the denominator equal to 0. And then when I will substitute x by 3, I will get something number which is not 0 over 0. So this makes the limits infinite, plus or minus. In this situation, I will, now it is clear, I will use, in fact, this factoring for all limits that I have. So that's why I wrote it here. Now I will compute instead of limit x approaches 3, I will take x approaches 3 plus, for example, because 3 will be, when I substitute x by 3 in the denominator, it will give 0, and in the numerator it's not 0. So that makes no sense to compute limit at x equal to 3. Just we compute 3 plus, for example. So when it is 3 plus, I will replace in the expression 3 plus minus 7, that's negative. Okay, so we can compute it. It's minus 4 times 3 minus 2, so 1. And here, x minus 3, when x is 3 plus, so it's 0 plus, okay, times 3 plus minus 2, that means 1 in terms of limit. So basically, I will get something negative in the numerator and 0 plus in the denominator. So it's minus infinity. If you compute a limit f of x when x approaches 3 minus, you will find that it is plus infinity, but no need, since this give me the conclusion that x equal to 3 is a vertical asymptote. Okay, now I will work on the limit when x approaches 2. So limit f of x when x approaches 2. And remember here my factoring. So it's here it is. But here is the factoring. So it's x minus 7 times x minus 2 over x minus 3 times x minus 2. And here we simplify by x minus 2. And now we substitute by 2. So 2 minus 7, that's minus 5. And 2 minus 3, that's minus 1. So the result will be 5. It's not infinite. So we conclude that x equal to 2 is not a vertical asymptote. This is a movable discontinuity. We will see it later, this concept of continuity and discontinuity. Okay. For now, it's a kind of limit. So my answer will be, of course, my conclusion. I can conclude that the only vertical asymptote is x equal to 3. And the answer in the worksheet is B. Okay. Now MCQ number 4. We want to evaluate the limit of x minus 1 squared cosine. You remember this is application of the squeeze theorem. So we have here the range of cosine, and it is minus 1 and 1. Range of cosine is equal to minus 1, 1. Then I can put any cosine between minus 1 and 1. In particular, cosine 1 over x minus 1, it is between 1 and minus 1. Now we will multiply by x minus 1 squared, which is non-negative. Okay, so I can multiply the inequality without changing anything. So it's minus x minus 1 squared less than the expression of my function. So x minus 1 squared cosine 1 over x minus 1. And less than x minus 1 squared. Now take the limit of this when x approaches 1. So this is approaches 0. And same thing happens for this, approaches 0 when x approaches 1. So by the squeeze theorem, this must approach 0 when x approaches 1 by squeeze theorem. Okay, so my answer is, of course, the limit equal to 0. And in the worksheet, this is D. Okay, now we can move to the essay part. Okay. Question 1 in the essay part. Use the graph to evaluate the following limits. We want for A, limit f of x when x approaches 6 minus. That means I am to the left of 6. Okay, so here is 6, so I am to the left here. That means I am approaching this point, which is 1. So the limit is equal to 1. B, limit 6 plus. So I am somewhere here, and you see the limit. So limit of f of x when x approaches 6 plus is equal to -1. By the way, we can conclude, of course, here. This is not in the question, but we can make the conclusion that the limit f of x when x approaches 6 does not exist. This is extra observation. Now C, limit f of x when x approaches 2. So I need to see right, left limit. This is 2, right, left in the graph. They meet at the same point, and it is equal to 1. Okay, so that's C. D, approach limit x approach 4. Okay, so this is the point 4. I will take right, left, approaching the same value, and this is the limit. When right, left, they meet at the same point, take the y as the limit, okay? When they don't meet, the limit does not exist. And by the way, we can have, be careful if we have two functions in the same picture, two graphs of the function in the same picture. So for example, we can give f and j, then be careful to choose the right graph for f or j. Okay, now we'll continue with the E. Limit f of x when x approaches 0 minus. So I am close to 0, but to the left of 0, clearly the function is going to plus infinity. Okay. The last one, limit f of x when x approaches 0 plus. So I am close to 0, but I am to the right of 0. So x approaches 0 plus. We see here that we are getting close to 0 for 0 plus here. Okay. So my conclusion for this is also extra observation. Limits at 0 does not exist since they are different. So the limit does not exist. Good. This is question number 1. Then I will move to question 2 for the essay part. Look at the question 2 here. We are given g of t, a function which is defined by intervals, so two regions, two expressions. We want to find c so that the limit at t approaches 2 exists. Okay. So here I need to compute, of course, 2 plus limit at 2 plus and 2 minus. So limit g of t, because the expression is changing from 2 to infinity and then minus infinity to 2. So since I am 2 plus here, it means I am close to 2, but greater than 2. Greater than 2, then I will take the expression number 2. So this is equal to limit of root t plus c when t approaches 2 plus. And now substitute, it will give root 2 plus c. I don't know here c, but I will keep the result like that and then continue to work on limit 2 minus. Okay, for 2 minus, I will use the expression number 1. Okay, here, I will use this one. So it is equal to limit t approaches 2 minus of 4 minus 1 over 2t. Then substitute t by 2. So 4 minus 1, that means 3. Now make the equality. To make the limit exist, we must have these two are equal. Limit g of t approaches 2 exists if and only if we have the equality. Limit t approach 2 plus equal to limit g of t approaches 2 minus. That means root 2 plus c equal to 3. And simple computation will give that, make the square root here. So it's not c equal to 7. 9 minus 2 is equal to 7. Okay, this is the question 2. Question 3, it's the same kind of question like question 2. So I will go a little bit faster here. Okay. The limit exists when right, left equal to, they are equal. But here you see that if we substitute, we will get 4 times 3, 12 plus 2k minus 2 over 4 minus 6 plus 2. So I will get basically 0 in the denominator and 10 plus 2k in the denominator. Okay? To make this exist, to make a hope for the limit to be existent, we should have 10 plus 2k is equal to 0. Because if this number is not equal to 0, then the limit will be infinite limit, and we will have limit to the right different than limit to the left, and it is infinite. So here the value of k will be, if we solve this simple linear equation, then k is equal to minus 5. Okay, now doing that, I have my k. I can factor my expression. So my limit will be limit of the function when x approaches 2, 3x squared minus 5x minus 2 over x squared minus 3x plus 2. Okay, now here we have to factor both numerator and denominator. Okay. it looks for the numerator a little bit not standard equation because we have this coefficient here, and maybe it's not easy to find the factoring in this case. If you find a difficulty to find the factoring by guessing, you can use the solving of the linear quadratic equation, 3x squared minus 5x minus 2 equal to 0. Okay, so you have your a equal to 3, b equal to minus 5, c equal to minus 2. Then you solve x equal to minus b plus minus root b squared minus 4ac over 2a. Here substitute, so it's 5 plus minus root b squared, that means 25, minus 4 times 3 times minus 2 over 2a, that means 6. This will be 5 plus minus 25, and this is becomes plus. So plus 24, 25 plus 24, 49, root 49, that's 7 over 6. And now I can separate the plus and minus. This is 2 for the plus, and 5 minus 7, that's minus 2, minus 1 over 3 for the minus. Okay, so I have my two roots. Okay, now, if you have the two roots, by the way, this is not, this is like, I did it to understand when we have difficulty in factoring, we can use the solution of the quadratic equation using the delta. Okay, so I have my two solutions, x1 equal to 2 and x2 equal to minus 1 over 3. Okay, now remember that in general, when you have solution of quadratic equation, then your imagine you have x1 and x2 solution, and you have a quadratic equation like that, ax squared plus bx plus c, and you find your two solutions, then the factoring will be a times x minus x1 times x minus x2. Okay, this is like a general rule if we have two solutions. And in our case here, 3x squared minus 5x minus 2 will be equal to 3. X minus 2 times x minus 3, so it's x plus 1 over 3. Okay, now we can put this 3 inside the second factor, so it will be x minus 2 times 3x plus 1. This factoring could be done without, of course, the solving of the quadratic equation. You can do it, but I wanted to give you one another method if you have difficulty to find the factoring. Okay, so another way. If you have the factoring, then do it directly, because the factoring is much shorter than solving the equation. Okay, now I have my factoring. I have also the factoring in the denominator here. Look at the expression. X approaches, sorry, not this one here. X approaches 2 of 3x plus 1 times x minus 2, that's for the numerator, over the denominator. Now the factoring of the denominator is not difficult, so it's x minus 2 times x minus 1. And clearly here we simplify by x minus 2. Then substitute x by 2, I will get 7 over 1, that means 7. Okay, so my limit for this question is 7. and the value of k is -5. So that's my conclusion here. Limit, let's say f of x, okay, we call this function f of x, x approaches to is equal to 7, and k equal to -5. Good. Now we go to question B. It's the same kind of question. As usual, now we can go a little bit faster. So I will substitute, I'm in this question here, x equal to -2. So it will give me 12 minus 2a plus a plus 3 over 4 minus 2 minus 2. So clearly in the denominator it's 0. In the numerator, so it's 15 minus a. So I must have a equal to 15 as usual to make a hope for the limit to exist. When a is equal to 15, then I will get factoring of the denominator, so it's x plus 2 times x minus 1. And in the denominator, it will be 3x squared plus 15x plus 15 plus 3, that means plus 18. To simplify this, I see that there is a common factor 3 in the numerator. So I will factor this by 3 to make it simpler. So 3 factor x squared plus 5x plus 6. And clearly now it will become easy to factor. So you see that x plus 2 and x plus 3. Okay, so evidently we have a simplification by x plus 2. So I will remove this and then I substitute x by -2. So it will give 3 in the numerator and -3 in the denominator. So the result is -1. So the limit when k is equal to a equal to 15, the limit is equal to -1. That's the only value to make the limit exist. Okay, now we go to the last question of this essay part, which is question 4. Okay, so question 4 is asking for the limit when we have this double inequality, and when we have double inequality in general, it looks like the squeeze theorem. So we have f of x between two functions minus exponential x minus 1 and 2 sine pi over 2x over x minus 2. And we want the limit when x approaches 1 minus, okay? So 1 minus, this limit goes to x is 1 minus, so it's like 0 minus, and exponential 0 minus it's 1. So it goes to -1 this way. X approaches 1 minus. Okay, now in the left part here, when x approaches 1 minus, that means pi over 2x approaches pi over 2 minus. What is the sign of pi over 2 minus? It's equal to 1. If we want to be precise, it's 1 minus, okay? Now I will multiply by 2, then divide by x minus 3. So it will give this limit here, this one, all these. It's 2 over minus 2. So it's minus 1. So it converges to minus 1 when x approaches 1 minus. It won't make a difference if we took 1 plus, I guess. It's the same thing. So my conclusion here with the squeeze theorem that by the squeeze theorem, we have limit f of x approaches 1 minus is equal to minus 1. Okay, without knowing anything about the function f of x, we don't know even the expression of the function. Just we have double inequality. We have bounds for the function f, so we could find the limit using the squeeze theorem. And we are done for this first worksheet. Thank you.